Welcome, hi everyone. So in this video, we'll basically go over um, the intuition behind the neural network and basically what is neural network, how we are going to apply that to the numerous machine learning problems, and then we'll also talk about and derive the math behind uh, the neural network functions, for example, cost function and um, forward and backward propagations. We'll take example of the binary classification, logistic regression, and we'll also try to apply a neural network, form a neural network based on the logistic regression model. So as you can see here, I've drawn here this a very basic kind of a neural network which represents the working of a brain. So we have neurons in the brain, and consider this as one of the neuron and this one as another neuron. So we'll have some electrical input to that neuron, and that will process the signal and send it to the another neuron with some different kind of a signal, or maybe a wavelength in terms of that. And then it will generate some other output function, and that will have some actions related to it. And so the same function is same architecture is used. It's not the similar kind of architecture, but it's the basic intuition is derived from the biological workings of the brain. So that has been used in developing the neural networks for the machine learning. So as we can see here in the white, this is the first hidden layer, and we have 3 neurons in that. This is just an example, just to go over the review of how the neural network looks like. And then we have the second hidden layer, and we have 4 neurons in that. And these are going to be the input features. And then we have the output feature over here. And this is the output neuron. So that's why we call this output layer. We have 2 hidden layers and the input layer. So this is the whole architecture. One of a kind of an architecture, which is just an example for over here, just to go over the basics of the neural network. There are certain reasons that we use neural network, which first of all, that it is robust. It is faster than other conventional machine learning algorithms, and it has good prediction values, and it can be mostly the area where we have images and videos and unstructured data, where it becomes very hard to classify or even predict them using the conventional algorithm. That's why the neural network plays a very big role. So if we talk about, even if we take an example of linear regression applied to housing price prediction example, we can definitely apply a neural network to a regression problem as well, and it might even provide good results. But the intuition is that for the harder problems, when it comes to using, for example, image data, where we want to convert the pixels into a very large array, right, or a vector. So what we'll have is a huge millions and millions of vectors or parameters, and then it becomes very hard for the conventional algorithms to utilize that huge amount of data and make changes to it, or even do the predictions. So that's why the idea of neural network. Apart from that, we will, like in this video, this is just going to be the overview of what we are going to talk about in the neural network. And nextly, in the next video, we'll start with the binary classification and logistic regression, which as an example we'll start to build the neural network taking the binary classification in mind. Then we'll talk about the gradient descent, the loss function, and how to calculate the forward propagation, back propagations, along with its derivatives. So we'll discuss in depth the architectural fundamentals as well, how to choose neurons and how the input features are actually decided, what are going to be the weights and biases, and how the output layer will decide the output of the whole neural network. So that's what we are going to talk about in the next coming up video. And that's all for this video. So thank you.